All right, sorry for the delay. Welcome back, students, parents, and teachers. My name is Daren Heaton. I'm the Executive Director for Science of Sport. My co-host today is Ricardo Valerdi. He's an engineering professor at the University of Arizona. For today's episode, we are talking about geometry. There are so many different shapes that are tied into sports, and we're going to be discussing that in more detail today. We're going to start off by doing an activity with everyone. I see there are a number of different students, so would love to get your guys' involvement in this. We're going to be utilizing the chat feature. Please stay on mute throughout this duration. So if you do have questions, comments, please make sure to use the chat feature, especially for this activity. Ricardo, so the way this is going to work here is we are going to go through some different shapes. And the goal for everyone that's participating in on this, we want you to think of that shape in the context of a sport. Let's just use one here, and we'll start off and we'll give you guys some time to see how this is going to work. So I am going to say a square. And what you are going to do is think of all of the squares that are tied into a sport. Specifically for this example, the answer that I would think of would be baseball, in which I think of a square that is being used in baseball. I think of the bases, the infield bases. That is in the shape of a square. Does that make sense, Ricardo?
Absolutely.
All right, everyone got it. So let's go through a couple of these then. I'm going to say it. Let's go with triangles. Think of where triangles are within any sport. It doesn't have to be baseball. It could be basketball, football, soccer, tennis, golf. Ricardo, you have any answer to get them thinking in the right mindset?
Triangle, yeah, football.
Okay, how is it? Elaborate a little bit more.
So if you're a quarterback and there's a wide receiver you're trying to throw to, there's probably going to be a triangular route that they're going to throw, that they're going to run, and you're going to throw at them at a hypotenuse, which is the large leg of the triangle.
Got it. It seems a little choppy on your end, but let me just try to make sense of that. If you're a receiver running route, you're a quarterback and you're throwing to a receiver that's running straight. The ball and the route in comparison to the quarterback is in the shape of a triangle. So that's a really good one. Another one that I just want to mention, and then we can get into the specifics of this webinar and episode, but really a pentagon. Can you guys think of where a pentagon is within sports? Pentagon has 5 sides. If you have the answer, put it in the chat. Well, pentagon is home plate, actually. So take a look at home plate here, and you'll be able to understand what a pentagon is. But that will get us kind of the juices flowing and get us in the right mindset for today's webinar. Again, it's focused around at-home STEM activities, whether you're a lot of students that are part of this webinar today, or for teachers that are looking to supplement some online learning opportunities. So we are Science of Sport. We're a nonprofit organization that brings math and science to life using sports examples. I saw some kids in the chat talking about Compton. We work with the MLB Youth Academies, and that's today's episode sponsor, and I am actually rocking a Compton Youth Academy shirt here, and we run some really unique programming with them at their youth academy specifically in Compton and New Orleans. Also work with a number of different their facilities. If you haven't been there, for those that are from Compton on this, definitely go by, check it out. They have free player development resources for you. All right, so again, as I mentioned, you are going to be utilizing the chat here. So whether if you're following us on Facebook Live, throw them in there or within the Zoom, and we'll get to your questions. But for today's activity, we're focusing on geometry. Ricardo, tell us more.
Can you hear me okay, Daren?
I can hear you vaguely. A little, yeah, it looks like it's a little choppy, but we'll get through it.
Okay, yeah, so I wanted to talk about geometry in the context of baseball and give some examples. So in order to do this activity, all you need is a worksheet, like a piece of paper and a pencil. So let's get right into it in terms of geometry in baseball. So if you look at the infield, I wanted to point out a couple of relevant dimensions. The first one is the distance between the bases. And you'll see there between first and second base, it's labeled 90 feet. Okay, and so that's an important dimension to know because that's the distance that batters or runners have to run in order to move from home to first to second, and so on. So we're going to go through a couple of questions and activities together based on just the dimensions of the infield. Okay, so let's go to the next slide. Okay, so the first thing, like to build off of what Daren was saying, is not just triangles or pentagons, but there are also many circles, squares, and rectangles. So take a minute to just appreciate from this picture how many different types of shapes exist in the typical baseball infield. Now, the pentagon that Daren mentioned is down towards the bottom at home plate. And that's important to know because that is where the batter stands. That's where the majority of the action occurs. And that's where the umpire is looking at in order to determine whether the ball is a strike or not. Now, I want to point out that every single Major League Baseball infield looks exactly like this. You'll see differences between stadiums in terms of their outfield wall, so the dimensions of the outfield are different. But here, we're only looking at the infield, which is the area that's inside of this graphic. Okay, the next example that I want you to appreciate is has to do with another geometric concept. So you go to the next slide. Because I mentioned to you the 90-foot distances, from that information, you could calculate the perimeter around the bases. So if you could punch into the chat, what do you think is the perimeter around the bases from home to first to second to third and then back to home? Daren, did my audio come through on that question? There we go. All right, the answers are starting to come in here. The perimeter of the infield, moving from home to first to second to third and then back home. That's correct. It is 360 feet, which is 90 feet times 4. All right,
Ricardo,
let's go on.
well,
Yep.
I want to mention something there. As you had said, the one thing that's consistent for every MLB ballpark is the infield. So everything that you're seeing on the screen here from those dimensions are going to stay consistent. Anything that is beyond that from the outfield walls, the distance to left, center to right field are different. And that's one of the coolest parts about baseball is each stadium is unique. But going back to the perimeter real quick around the bases, I found an interesting stat and would be curious if some of the students, if you want to respond to the group or to Ricardo or myself, what do you think the average time for a Major League Baseball player to run all around the bases from home plate once they hit it and past first, second, third, and back to home? Would be really, we'll come back to that, but if you want to move on to the next, I'll give everyone some time to think about it.
Yeah, I do want to move on to the next. It looks like my connection's a little better, so I'm going to share my screen, if that's all right. Okay, can you hear me better, Daren?
So much better. Yeah, sounds great.
Okay, great. So, so we've talked about perimeter. The next thing I want to talk about is area. So if you could punch into the chat, what do you think the area is of the infield? Again, 90 feet between bases. And just to give you a hint, this is a square. The infield is a square from home plate to first base to second base to third base and back to home. That's a square. So the question is, what is the area of the infield? All right, that's correct. It's 90 feet times 90 feet, which equals 8,100 square feet. Excellent. Good job, everybody. All right, we're making good progress here. Okay, here's a hard one. I would like to see if you can guess what the distance is from home plate to second base. So we know that the distance between bases is 90 feet, right? But I'm asking something slightly different, which is, what is the distance between home plate and second base? All right, some people are just doubling the distance, but Manav, looks like Manav's got 127.28. That is the correct answer. Let's talk a little bit about how to do that. So we're gonna inquire some help from our friend Pythagoras. And he's given us the nice shout out, a squared plus b squared equals c squared. So if you treat each of the sides, we know are 90 feet. That is the two legs of the triangle. And c squared, the hypotenuse, is what we're trying to solve for. So let's plug in some numbers. If we know the value for a squared, that's 90 feet, and the value for b, 90 feet, and square that, we know that equals c squared. So 8,100 plus 8,100 added together is 16,200. and then you take the square root of that, and you get 127 feet. Now, that's important because that is the distance that the catcher has to throw in order to get the runner out if they're stealing second base. They're running from first to second base, and the catcher wants to catch them and get the throw in there in time before the runner gets there. Then that's the distance that they have to throw. So that's very important for catchers, very important for everybody to be aware that it's not just 90 feet or it's not just 180, it's 127.27. So just to summarize, this is what the triangle looks like with the dimensions filled in. So good job to those of you who got that one. Daren, what do you think?
Yeah, nice work for those that got it. If you guys have been thinking about my question about how long it takes for an MLB player to run around the bases, on average, 16.7 seconds. Can't even get to the fridge in 16.7 seconds.
Yeah, that's right. That's very fast. And that's with a lot of adrenaline running through the system.
Right. And, you know, I think it's worth mentioning that reason why they're able to run so quick, and it kind of goes to the numbers that we were looking at here as far as the distances between bases. Even if a player were to run the shortest distance, doesn't necessarily mean that they'll get there the quickest. And the reason for that is angular momentum. Ricardo, you want to explain that?
Yeah, angular momentum is when you're running in a circular path, not in a straight line, but you're running like if you think of an Olympic track, you're turning left. Angular momentum allows you to not fall by leaning into the turn. So if you think of like the high-speed motorcycle races, how the motorcycle drivers lean into the turn, and the reason they do that is so that they don't fall over. So if you don't lean and you stay straight, the centripetal motion will actually push you away in the opposite direction. So leaning actually helps you maintain constant speed.
Great. I mean, that if you want to run the bases in 16.7 seconds, you need some angular momentum, that's for sure.
Absolutely. Okay, the last part of this webinar is we're going to tell a couple of jokes, and this is how it's going to work. If you've seen those YouTube clips on dad jokes, they have these competitions where if you laugh at the joke, you lose. So Daren, I'm looking at you, and I'm gonna tell you a joke, a baseball joke, and if you laugh, you lose.
Okay.
All right.
Better be, let's see what you can come up with.
Good. These are so good. Okay, Daren, what is a baseball player's least favorite Star Wars movie?
I don't know. What is it?
The Empire Strikes Back.
Cool. It's a good one.
I see a smile.
That's not a laugh, though. That's not a laugh.
I got you. All right, I'm going to try another one. Here we go. What did the baseball glove say to the ball?
I don't know. What did it say to the ball?
Catch you later. You're fighting it. I see you're fighting it.
The first one was better than the second one. You got more?
I got just one more.
Okay.
Did you know that baseball is the first sport in the Bible?
I did not.
It's in the book of Genesis, in the big inning.
Oh, man.
I got you.
Jeez, I know you have more too, and this is just scratching the surface.
I do, but I only have so much time today for a webinar.
Yeah.
So yeah.
Very cool. Well, thanks for all that joined, and go check out our social media accounts, our YouTube page, so much more resources for you on there, including some step-by-step videos you can watch to be able to do some stuff at home. That's not just sitting in front of the computer, out in the yard, in the driveway, in the living room, where you can work on some additional STEM activities that are focused around sporting examples. That's it for today's episode. Thanks for coming. If you have any questions, email us at info@sciencesport.org. That's it for now.
And
See you later.
Thanks to Mr. Robbins for joining us today in his class. Appreciate it, guys.